The power series is something we've looked at before. At least I showed you an example of it. It's going to be a way of writing functions, or at least we're going to use this idea to write functions as a polynomial. And you can write almost any function as a polynomial, at least on certain intervals you can. It actually allows us to write like the sine curve as a polynomial. A power series is a polynomial, and a polynomial is a function written in this form, where it's a constant times different powers of x. So we have, in this case, some constant plus a constant times x to the first, plus a constant times x to the second, plus a constant times x to the third. And what these power series are going to allow us to do is to write certain functions that are not polynomials, like sine, or the natural log, or the exponential function. It's going to allow us to write them as polynomials, and we want to do that because working with polynomials in calculus is a lot easier than working with other types of functions. Why is it easier to work with polynomials in calculus than other functions? It's easier to take the derivative and the integral because we have the power rule. You guys remember the power rule? The power rule is really easy with polynomials. If we start doing things with sine, cosine, natural logs, and they get a little bit complicated, then we have to start worrying about chain rule, and we have to start worrying about all kinds of other stuff, and it's not as easy. So the power series is really useful, really powerful, pun intended, because we can take derivatives and integrals very, very easily. This is a power series that's centered at x equals 0. That's this note right here. There's also such a thing as a power series that's not centered at 0. This should be a 0 here. It's not centered at 0, but it's centered at some constant a. So basically what we can do is we can take a power series and we can shift it by a by subtracting a from each term. You don't need to write this down. Understand that this exists, and we'll get back to it later on when we start doing Taylor series.